Okay, cappuccino. Sorry I am not there again today. I'm still not feeling good. But this is what we would be doing, or you would be doing on the whiteboards if I was there. So I'm just going to do it for you on this video. See if I can focus that any better. You need to find all the missing sides and all the missing angles. So if you want to test yourself, you can pause the video right now and see if you can figure out all the missing side lengths, like this one, and the missing angles, like this one and this one. Okay? All right. Back from our pause, I'm going to go ahead and show you how I would do it. So on this triangle, I notice it's a right triangle, so I can use the Pythagorean theorem. I know that this side squared plus this side squared has to equal the long side squared. So I'm going to call this x, just so I have something to talk about. And so the x side squared plus the other leg squared has to equal the hypotenuse squared. So if I multiply that out, I get x squared plus 144 is equal to 169. I'm then going to subtract 144 from both sides to get the x squared by itself. And that gives me 25. And then I need the square root of 25. X is equal to the square root of 25, which of course is 5. So this side is 5. Okay, now though, I need to figure out the missing angles. So usually for angles, we use Greek letters. Theta is a Greek letter, so I'm going to use theta. For this one, I'm going to use a different Greek letter. I'm going to use alpha. This is the Greek letter alpha. So just like we use x, y, and z all the time for variables, that's from the Latin alphabet, I can also use letters from the Greek alphabet. So this is alpha, this is theta. They're just letters from the Greek alphabet. All right, so if I want to find theta, I know that the tangent ratio, the slope ratio, is 5 over 12. So 5 over 12 is equal to the tangent ratio of theta. So I can take my calculator, and this is a different calculator than the one that you have. So I'm actually just going to do 5 divided by 12 and get my answer. That'd be 0.41666666. And I'm going to see if I can find it on my table. So remember, you have this table in your notebook. So I'm going to be looking for the tangent ratio is 0.41666. So I'm looking at, it looks like it's between 22 and 23 degrees. So I think 416, it's probably going to be closer to this one. So I'm going to say it's 23 degrees. So theta right here is 23 degrees. Okay. On this calculator, I wonder if it works the same as yours. I think it does. I'm going to also do it the calculator way. The calculator way, you have a different calculator. Sorry, I don't have your calculator here at home with me right now. You would do second and then tangent and then put in 5 over 12. This calculator is a little different. I have to use shift and then tangent. See how it gives me tan to the -1? That's called the arctan or inverse tan. It tells me that I want to go backwards. So I'm going to give it the ratio, which is 5 over 12. And then I'm going to hit equals, and it'll tell me what the angle is. You see, it says it's 22.6 degrees. So on my table, I said I thought it was closer to 23 degrees. Closer than it was to 22. And then if I actually do it on my calculator, it says it's actually 22.6 degrees. And if I round that off, I would get 23 degrees. So I'm perfectly fine with my 23 degrees. Now to get the third angle, I can use the fact that all three angles have to add up to 180. So alpha plus 90 plus 23 has to equal 180. I can subtract the 90 from both sides, so alpha plus 23 has to equal 90. So alpha has to be equal to 90 minus 23. So 90 minus 23 gets me 67. So there are all of my missing pieces. I have my two angles, 23 and 67, and I have the missing side, 5. All right, on to the next one. So that was nothing new there. We've seen all that before. Okay, this one I do have an angle and I have one side. So I'm thinking, let's do our tangent ratio. So again, I'm going to call this x. So I know that x, gosh, the internet keeps breaking, x over 20 is equal to the tangent of 27. Because if I put my finger on here, this is the opposite. This is the adjacent. It's a nice slope triangle already, rise over run. So now I can either use my table, and look up the tangent of 27. Tangent of 27 is, I just saw it, it's 0.5095. So 0.5095 is equal to x over 20. I can then put this over 1, and then I can do my cross multiply. So I get x is equal to 20 times the tangent of 27, or times 0.5095. Grab my calculator. So I can do 20 times 0.5095, and I get 10.19. X is equal to 10.19. So 10.19. That's my x. Or I could have done it with using the tangent button in here. I could have done 20 times tangent of 27. And I got the same answer, 10.19. Okay, I like 2 decimal places is nice for side lengths. For the angles, nearest degree is fine. All right, so to find my missing angle here, again, I'm going to use the fact that the 3 angles have to add up to 180. So I'm going to have 90 plus 27 plus, I'll call this alpha, plus alpha has to equal 180. If I minus 90 from both sides, I get 27 plus alpha equals 90, and then subtract 27 from 90. So 90 minus 27 gives me 63. So my missing angle here, my alpha, is 63 degrees. Okay, now I'm missing the hypotenuse. So I can use Pythagorean theorem to help me find the hypotenuse. So I now know this side. It's 10.19. So it's the square of that. Remember, if I draw a square on it, the area of that square plus the area of this square has to equal the area of that square. So 10.19 squared plus 20 squared is going to give me, I'm going to go ahead and call the hypotenuse h, is going to give me the hypotenuse squared. So again, back to my calculator, 10.19. I want to square that. There's actually, oops, I got too many numbers in there. 10.19. There's actually a button that says x squared. That's a little shortcut. And I get 103.8361. And then 20 squared is 400, because 2 times 2 is 4, and I've got to have 2 zeros. There's h squared. I can add those together. So I still had it in my calculator, so I'm just going to get the plus sign and then add 400. So I get 503.8361 is equal to h squared. So to get my hypotenuse by itself, I need to do the square root of 503.8361. Notice I haven't rounded off yet. This is a good habit not to round off until the very end. So I'm going to clear that out. There's probably a way to save it, but whatever. On this calculator, my square root button is all by itself. But remember, on your calculator, you have to hit the second and then x squared and then put in the number. On this calculator, I can just choose the right button, 0.8361. So I need the square root of 503.8361. And I get 22.45. So notice I'm going to round it off like dollars and cents. So I want to stop here at the second 4. So I look to the right, 5 or more, give it 1 more. 4 or less, don't you mess. 6 is bigger than 5, so that becomes a 5 instead of a 4. So my hypotenuse is equal to 22.45. Okay, so again, this is work that you would have done on the whiteboards. If I had been there, you would have done this working together. So now we'll look at the next one. And notice I have the hypotenuse, and I have one angle, and I don't have the other 2 sides. Well, I know that I can find this angle, and check this out. This is 27, this is 27, that's 90, that's 90. So, hey, that has to be 63 degrees. That was easy. And then I noticed something else. Wait a minute. These two triangles are similar to each other. So this one, my hypotenuse is 193. This one, my hypotenuse was 22.45. This was 22.45. Is my hypotenuse. So since I don't have either one of these legs, I can't use the tangent ratio. So I'm thinking maybe what I can do is I can use the fact that these are similar triangles. And let's figure out what my scale factor is. This is the bigger one. So I need to multiply 22.45 times something to get 193. So I can figure that out. I can get my scale factor by doing 193 divided by 22.45. Remember the new one divided by the original one. I can get my scale factor. Boy, we haven't done that in a while. So if I have 193 divided by 22.45, I get 8.5968. Holy cow. So if I round this off to dollars and cents, the 6 makes the 9 go up, which would become a 10, which means I need to carry my 1. So this would be 8.60. So 8.60 is my scale factor. So now I can multiply each of the sides from the smaller triangle by my scale factor to get these two sides. So to get this side, which I'll call this A and I'll call this B, A is going to be equal to the scale factor times 20, and B is going to be equal to 10.19. Oh, sorry. Let's do it in the same order that I did before. The scale factor, 8.60, times the original side length, 10.19, and I'll get my new side lengths. So I already have this in the calculator, so I'm just going to times it by 20. And I got 171.94. 171.94. And then this one, I have 8.6 times 10.19, and I get 87.63. 87.63. Now, just to be doubly sure, sorry, you couldn't see that. Just to be doubly sure, I'm going to do the Pythagorean theorem on this and make sure that they actually work. So if this side is 87.63 and this side A is equal to 171.94, I should be able to square these, add them together, and get 193 squared. So let's give it a try. So 87.63 squared plus 171.94 squared should equal 193 squared. So fingers crossed. Let's see if it works. So I'm going to type it all in. 87.63 squared plus 171.94 squared equals 37242. I'm not going to worry about the decimals. 193 squared is equal to 37249. Really close. Really close. I'm going to say close enough. Something must have happened with my rounding at some point that I got a tiny bit off, but it's almost the same. So there it is. That was like a complete review of everything we've been doing with triangles. We have the sum of the angles inside of a triangle equals 180. We have our tangent ratio to help us find missing angles and to help us find missing sides. We can use the tangent ratio. We did that over here. And Pythagorean theorem, when we know two sides, we can find the third side. And similar triangles. When we have two triangles that are similar, we can find the scale factor and use that to help us find missing parts of a scale factor. All right, so that's the review portion of the video. I'm going to take a break here and I'll start a new video with the new stuff for today.